Hi there friends, so nice to see you. Here we have such an interesting problem. We are given a triangle, and within this triangle we know OC, which is the distance from the center of the inscribed circle to the vertex, and also we know the radius of this inscribed circle, as well as the length of the side opposite to this vertex. We're asked to find perimeter and area of this triangle. Looks like we're lacking data, but that's not really the case. Everything is fine. Let's see what we can find first. Well, we know that the radius drawn to the point of tangency, to the tangent line over there, would be perpendicular to the tangent line, like this. Let's call this point H. And in this case, we know that OH is perpendicular to HC, means OHC is a right triangle. Therefore, we could use Pythagorean theorem, right? Well, HC in this case equals square root OC squared minus OH squared, which means (25) minus 16, which is root of 9, right? And it's 3. Well, HC is known, and we can mark it here. After that, we do know that if we draw tangent lines from the point outside of the circle to this circle, then the segments to the points of tangency would be of the same length. Okay, therefore we could already say that okay, this is also 3, and then we will know that AH would equal to this kind of length, and let's call this point probably K, and M. Well, KB would also be equal to BM. Well, let's call it X and Y. That will be simpler. X and X, Y and Y. Again, we have two unknowns, but that's not a problem. Let's try to find perimeter right away. Okay, so perimeter of this triangle is twice 3, twice Y, and twice X added to one another, right? Yeah. So 2 times 3 plus 2x plus 2y. 6 plus 2 times x plus y. But wait a minute, we do know that AB is 30, x plus y is 30. Means even though we do not know it, kind of each single piece yet, but we can say that x plus y is 30. And we can find perimeter. 6 plus 2 times 30 gives us 66. Okay, sounds great. We do know perimeter now. Well, how to find the area? Area requires either some height, or some angle sign. But there is one more option, which is as follows. Area is half of perimeter or semiperimeter times the area, the radius of an inscribed circle, okay, of the inscribed circle in this case, means we know everything. Let's do that. 66 over 2 times 4. The radius is 4. 33 times 4. 120 and 12, 132. This is it. We know the radius as well. So this is found, and this is found. Basically, actually, this problem I'm rewriting, re-recording, since I made a mistake, a very silly mistake last time, being in a hurry. I just didn't check the sides and the way they should kind of complement each other. And thanks to some viewer, I've got a comment, so not to confuse anyone. I deleted the previous video and I'm making a new one. Yeah, I should be really more attentive, so more careful to double check all the sides, all the lengths before I post the problem. But basically, again, firstly, we try to figure out whatever we can do with the given data right away, okay? As like we found OHC triangle as a right triangle, and then we calculate HC as 3 based on Pythagorean theorem. That was good, but then we tried to apply anything. So basically, we were kind of lacking the lengths of the sides, but we had our theorem about the point outside of the circle, yeah, from where we draw our tangent lines, and the distances to the points of tangency would be congruent. Therefore, CH equals CM right away, yeah, and then AH equals AK, and so forth. And then just writing down perimeter in a different way, we found it out, okay? And then for the area, we have quite some formulas, let's say, okay, not only one. I wouldn't say there are several, but there's much more than one or two. Please learn math, learn geometry. It really helps us staying kind of creative, solving those problems. I wish you great success in your math studies, in your geometry studies. See you then, and bye.